We have previously seen that the vector product is a vector, and we have learned how to determine the components of this vector. Now it's important to say that this vector, or the magnitude of this vector, is given by the product of the magnitudes of both vectors A and B multiplied by the sine of the angle between these two vectors. It is also important to say that the vector product is orthogonal to both vectors A and B. So if we have here vector A and here vector B, the cross product is a vector that is orthogonal to both vectors A and B. Now let's see something interesting. I'm gonna represent vectors A and B here. Vector A and vector B. The angle between them is denoted by theta. And let's consider the parallelogram that is determined by these two vectors. This is the parallelogram that is determined by vectors A and B. The height of this parallelogram is this vertical dashed line, and I'm gonna denote it by letter H, and we know that the height is equal to the magnitude of vector A times the sine of the angle theta. So the area of the parallelogram is equal to the base, that is the magnitude of vector B, times the height. So we may write magnitude of vector B times the height, that is equal to magnitude of vector A times the sine of the angle between the two vectors. So we may conclude that the magnitude of the vector product between A and B is equal to the area of the parallelogram that is determined by vectors A and B.